Thank you for joining to this workshop about how to interface an ADAS. I'm Guillaume Adam from customer service of AVSimulation, and I'm with my colleague Sylvain, who will be managing the chat. So don't hesitate to ask questions during the presentation. We try to answer at the end, and if we don't have time, we will send the answer by mail afterwards. So make sure to let your name along with the question. So today's topic is how to interface an ADAS. So I will make an introduction of scanner global features and how they can help for which one will help for ADAS. And most of the presentation will be a dive-in of what steps do you need to do concretely inside of scanner to connect your ADAS system. So a quick introduction about simulation in general. Today, everyone does simulation because the most obvious reasons are we have more and more expectations in terms of security, of safety of the systems, and in the same time, they are becoming more and more complex, with typical ECU having about or more than 6,000 requirements, millions of codes, and it's going up and up from here. So obviously simulation is required at this point. Simulation helps you in from the beginning of the design of a vehicle up to the production. So you have challenges all along the way. You need to develop, for instance, ADAS. Of course, you need to make them work well, but you have other challenges. Like, for instance, you have made a good ADAS, but are you sure that it will be accepted by the customer? For instance, we are thinking about maybe the older customers. Will they use it as expected? Will they accept it? And so, for instance, you can put a customer inside of simulator, see how it works, and see how to build trust with your ADAS. You have you want to reduce time to market. You don't want to wait for prototypes. You don't want to wait for test conditions that you don't have control over, like, for instance, weather. You don't want to wait for that. With simulation, you can just test right away. Simulation will help you to validate your systems by driving millions of miles, getting a variety of conditions that would be hard to get in reality in the same time frame and costs. And more, we are moving towards certification with simulation. For now, okay, and so on. So Scanner Studio was designed in this spirit of all these challenges that you have. And so we have developed recently a new packaging, a new repartitions of scanner features into packages. The first one, the main, being Foundation. Foundation is has all you need to start simulating. Okay, so it's standalone, and theoretically you don't need anything else to do simulation. You have it's an all-in-one, but in order to match your objectives, we have made different additional packs that you will take and use with Scanner. So the packs are in two parts: the what you want to do. So for instance, you will want to simulate ADAS systems or headlight systems. You want to do vehicle dynamics or human factors, or you want to do several of them. It's not exclusive. And how you want to do. So the packs are in two parts: the what you want to do. So for instance, you will want to simulate ADAS systems or headlight systems, or human factors, or you want to do several of them. It's not exclusive. And how you want to do. So So, for instance, you want to do HIL, you'll connect to real-time targets, you will do massive simulation, or you will use a simulator, etc. Just to illustrate what I said when foundation includes everything, quotes and quotes, because with foundation you get the complete systems. Just so you have all different modes to start preparing designing your study, simulated analysis. You have the modules, the essential modules that allow you to do the simulation, render the view, etc. You have that many tools, and you also have data sets. Okay, you are not left with an empty simulation engine. There are already 3D environments, some vehicle models, and if you don't want to bother creating yours because you don't have, and it's not the main focus of what you are studying, then it's already available in Scanner. Okay. And on top of that, when you have the very basic simulation, you can add the modules, the packs that interests you in particular. Now, for the subject that interests us today, how to test and validate an ADAS with a AVSimulation product. You will take obviously the foundation pack, but also an ADAS pack, which gives you a set of features I'm going to present. And optionally, you can take the physical-based sensors, which are additional, more low-level sensors. Okay, and these features are available to work with virtually all the ways of simulation. You can do VIL, HIL with the real-time target pack. You can also use it for doing massive simulation. You can use it on simulators. You can use it with scenarios that are already reproduce NCAP and other regulation certification. Just to explain a bit more what I said about different kind of sensors when taking the optional physical-based sensor pack. A sensor for ADAS has 3 different steps. So the first step is to sense what is on the road. We have raw information, and then there is some perception algorithms, which could be said as thinking, which allows to recognize what is actually in front of my sensor. Is it a car or is it a pedestrian? And finally, the ADAS, based on that information, can take a decision. So physics sensors that are included in the first pack give you the raw data. It's useful if you want to train or to test your perception algorithms. You want to do some HIL, and you can go up to validating your ADAS that use these perception algorithms. On the other hand, ADAS also includes sensors. These ones are with what we call functional, so they are more ideal, and they give you the data that is already labeled. Basically, you get the information like the pedestrian detected with the coordinates, the relative position, etc., speed, etc. Okay. So that will be used for studying ADAS, so to feed an ADAS model, or to study the reaction of a human in front of an ADAS system. So concretely, inside, when using scanner, what is the architecture that you will have to connect your ADAS? We'll introduce a schematic for that. So on the left, you have the scanner feature in blue, okay, in blue squares. That's what the AVSimulation product. And in orange, you have what you want to test, your system under test. So for example, you have an ADAS model that is made in Simulink, or it's ECU, or it's something else, and you want to connect it to a simulation environment. Okay. So with the foundation pack, you get everything you need to design your experiment with the rich environment and metrics measurements. Okay. And in order to connect, you will want to simulate sensors. So sensors come with the ADAS and physical-based sensor packs. Okay. And when you simulate the sensors, you can also access the sensors output in real time using the API that's provided. So typically, you will get something like an object list, or if you use physical, that will be raw data from sensors, like a Doppler map or whatever. And you can, using the API, feed your ADAS system with simulated world information. And similarly, with the same API, you can, once the ADAS system has taken a decision, you can control the vehicle with commands, either with the pedal and steering wheel values, or by a commanded speed, depending on the level that you want. So the green blocks are the customer interface. It will match the list of inputs and the list of outputs that you want in the interface that you want, whether Simulink or something else. This block, you have everything that you need to do it yourself. Otherwise, AVSimulation proposed a service. We are used to create this kind of blocks for the customers. And that is not exclusive to the other features of Scanner. So when you have your ADAS system connected to Scanner, the simulation runs. It's a closed loop. And for the other blocks, it's as if the vehicle was a normal vehicle. So you can add to that some monitoring system if you are on a simulator to track a real human when confronted to the ADAS. You can continue doing headlights, advanced vehicle dynamics, while having your ADAS connected. Okay, so now I'm going to dive into Scanner, what steps are needed to connect the ADAS that you bring. So we have chosen to make the demonstration using Simulink. So the object of the demonstration is to show how to connect a Simulink block that would be your ADAS. And so the demonstration comes in 3 steps. The first steps I will show you how to prepare the Simulink model. And in the second step, how to do a co-simulation with Scanner and Simulink aside. At the end, I will show how to compile your model in case you want to use it as an example. So on the Simulink side, for starting, we have a tiny bit of preparation for Simulink to do, and connecting the ADAS. So basically connecting the inputs and the outputs to Scanner. Okay, so at the first launch of MATLAB, we have a few operations to do just to prepare using the Scanner blocks that are provided. So we can navigate to the API folder of scanner, the scanner installation. So the default folder is d/AVSimulation/Scanner Studio 2021/API. And here, in this folder, Studio 2021/API, we have a bunch of scripts, notably rebuild scanner and setup scanner. So rebuild the scanner makes is good to do once after the installation of scanner, but that's it. No need to call it afterwards. However, the setup scanner is one that you would call every time that you start Simulink. Okay. So here we just started the rebuild scanner makes. It takes a bit of time, so I'm just going to accelerate a bit. And when it's finished, we can start the setup scanner, which is the only one to call when you want to use the Simulink with scanner every time. Okay, so it's much, it takes less long time. What it does is that it sets some path, and at the end you will have in the Simulink library all the blocks that will allow you to work with scanner in Simulink. Okay, when it's finished, you can just open we are just opening a blank, a new Simulink model to go into the library and check that we have in the library browser, we have new sections. We have scanner APIs with everything that we will use from now. So we can start from a blank page. It's quicker to copy a sample that we prepared, where you have the block prepared. So here we just navigated to the samples folder under Scanner API and Simulink, where you have some ready-to-use models, Simulink models, and API control is a good basic example that you can copy and start from. We call it the new one that we are working to work with now has been called AEV. Okay. And we get, because we copied, we get these two blocks. The first block is a launcher, which allows you to control scanner from Simulink. We are not going to use it here. And the second block is a controller. So this one allows you to connect to scanner. There is so two main parameters that are important to set. The configuration is the name of the scanner configuration that will be used. You'll see later that I will use UTAC 2021 as a name, and the process name is the scanner module name for this model that we have arbitrarily chosen to be Simulink. Okay, now that we have the base, we need to get some inputs from scanner. So for that we have blocks, and so the blocks are found in the library browser. We navigate into the Scanner API network inputs, and we get, for instance, a block for reading a message that is sent by scanner sensors, a sensor message that is called sensor movable targets, and we can drag and drop it inside of our model to read the value from scanner. So I'm just pausing here to show what you get from this block. So it's everything that is detected by one sensor inside of scanner. So you get information like the date of update in simulation time. You get a target array. Let me take a pointer. Okay, that is called sensor movable target array. It's a list of targets. So it's a list of objects, but in Simulink it's a vector, simply. You get the targets array count, which is the quantity of detected targets inside of the array. And you get the index of the nearest target, which is useful in your case. So the array of movable targets is a vector inside of Simulink, so we just need to hash it to cut it in the different movable target. So we are just going to separate each member by doing some standard Simulink operation. Okay, we just use the subsystem to make it more clean. So this subsystem will use a block that is standard Simulink. It's a multi-port switch of 2048 inputs, and we choose one of them, one of this value. So it's just standard Simulink. So I'm just going to the end and show what it does. At the end, we get this block that takes the targets array as an input, and also the nearest target index. So basically, at the exit, you will just have the object, the movable target object, that is the closest from the sensor. This nearest target is still a vector in Simulink. It's an object, and you need to demux it. So for that, you have a demux block inside of the Scanner API library. Okay, it's inside the group structures, and if you get down, you will find a demux for the object movable target. And now that it's connected that way, at the output of this block, we have all the information relative to the closest target of the sensor. So we get information like the type, if it's a pedestrian or if it's a car. We get the position, the speed, etc. And we can use this to feed your ADAS block that we will insert just here. For the purpose of the demo, we have prepared a very simple AEB model, which we have put inside of a simple block, the green block here. So I'm just going to copy it and paste it inside of the Simulink model. Okay, and we can so connect the inputs. What this block does, it's a very simple emergency braking system. It takes the distance to the closest object in front of the car, so in front of the sensor. And with the parameter on top that is called distance, when distance to the collision is lower than 20 meters here, because we have chosen a constant, then we will put a maximum of pressure onto the brakes. So we can see the exits, the outputs here of the block are commands for accelerator, brake, pedals, clutch of the car. So we want to feed back these commands into Scanner. It's exactly as when we measure the value, we got value from Scanner. There is the mirror block and there is a block for sending value to the vehicle inside of scanner. It's called model cabin cap2 model. And it takes as input accelerator value, brake value, clutch, etc. So we just have to link, and that will be fed into scanner. For the vehicle of ID 0, here it's a parameter of this block that we could change. And for the rest of the values that we don't have dynamic commands for, we can just use constants. Going to a bit further. Yeah. So we set constants for the input we don't command directly. And when we have that, the model is almost ready. So we have the input parts on the left that is taking information from scanner. The ADAS, your ADAS is in the center. It takes the value from the sensor, takes a decision, and apply the cabin command onto scanner with the blue block. There is just one last thing to check for this model. It's the compilation target. Needs to be set to one that is provided with scanner. So here we have taken a sample, so it's already set to the correct target file. Okay, if you start from raw, just set. You just have to set it here, and that's good to go. Now, step 2. We will go into scanner this time to prepare the simulation that will work together with Simulink in the same time. For this part, I will show it on my own instance of scanner on my computer. Okay. So, Sylvain, can you confirm that you can see my scanner?
Yes, we see your screen. We see your Scanner Studio. Thank you, Guillaume.
Okay, so I just switch into scanner. We are going to create a scenario that is able to co-simulate with Simulink. So for starter, I want to show that I'm using a UTAC configuration. It's the so it's a set of scenarios provided inside of the Euro NCAP pack, and it's actually the trial version, so you can get this one. And I'm going to use it to demonstrate how to connect to the ADAS. So the first thing we will want to do is to create a module that add a module to this configuration that will communicate with Simulink. So I add a process and I just call it Simulink with no executable, no need. It will be the Simulink instance. Add, yep, okay, and we are good. From the UTAC library of scenarios, I'm going to use a simple scenario. So I just do, sorry, I'm going a bit fast, file, open scenario, and I'm going to use a scenario that is made for testing emergency braking. Okay, so in this case, I'll take one from the pack Euro, NCAP, AEB pack, and this one. So there are not all scenarios because I'm using trial, but it's still here. Okay, so I'm using this one. So what we have is a simple scenario with a go car and some target car that we will drive to, and we don't want to collide. So to generate sensor data, we need to put a sensor. Need to add a sensor to this ego vehicle. Okay, and for that, we can go into resources, and all the way at the bottom, you have so a bunch of sensor models and sensor configuration that are ready to use. Sorry about that. So I have prepared a configuration that is called Navet. If I double click on it, I can see the content. So I have inserted the radar inside. I'm not going too much details into the configuration of the sensor, but basically this radar has a sensor model, so a field of view that has been set, a set of detection capacities properties, and we have set also the configuration output. They are, we can detect bounding boxes, anchor points, like the center points of the targets in the reference frame of the sensor. So this guarantees that we will output the movable target message that we are reading on the Simulink side. So I'm just taking this configuration, this sensor configuration, and drag and drop it onto my vehicle to apply to it. And to see exactly what happened, I can go into layers and activate sensors, so I can see the field of view of my sensor. And during the simulation, in order to simulate this sensor during the simulation, I will need a sensors module. So we'll add it to my configuration. Add process, sensors, okay, and that's it. So if I go into the simulation pan, for a recap, I have the scenario with the correct sensor, which I can save. I have all my modules ready to start, and I have also this Simulink module. That is the one that will represent Simulink in our case. Now, I don't have Simulink on my computer, so I will switch back to the video. Where we have the same setup like I just did on my computer. So we have the ego vehicle on the map with the set sensor. We have the modules, including sensors and the Simulink. Okay, and we will start both the Simulink model and scanner simulation together. So the first thing is to start the Simulink model that will first compile and start simulating. So if you can see at the bottom, the time is running, so it's simulating. And inside of scanner, on the right in the simulator status, we can see that the module Simulink is in status green stop. So that means it's ready to be simulated. And the communication is established. Okay. So now we can start the other module from scanner with the blue arrow. That is the result sheet from specific from UTAC. So we get the results inside of it at the end. Just discard it for now. And when we start the simulation, so the two models will start to communicate in real time. The closed loop will be in effect. And when reaching a distance of less than 20 meters to the car in front, the AEB will activate and press the brake pedal of the ego vehicle inside of scanner. We've reached 20 meters, so the brake pedal was activated. And the simulation stops automatically as set in the scenario. Okay, and that's the result sheet from the UTAC CERAM test process, simulated test process. So we have a green result for the case we just run. Okay. So so we just did co-simulation that requires that you have Simulink and scanner as, next to each other. They don't need to be on the same PC, but they need to be running in the same time. So you have another option, which is to compile the model. The Simulink model doesn't have to be running inside of Simulink. It can be compiled into a binary, and we can use it afterwards inside of scanner as a classical module. So the process for that is pretty straightforward. Inside of Simulink, just select the compile button, which is on the top of the screen here. Just press it. I'm accelerating a bit. At the end, we get a .exe, which matches the model we have made in Simulink. Just for convenience, we can copy the exe and put it in a more convenient folder like the bin folder of scanner. So that's that. No, we don't need scanner Simulink anymore. We have the exe file. So I can show it on my computer. I have the exe file. I won't use the Simulink module anymore, so I can remove it inside of configuration manager. The Simulink will not be used anymore. Actually, I'll just keep it and not use it. Okay, and instead I will use add a process, and in the executable field, I will choose the AEB folder the AEB file that I just saved from Simulink. Okay, so I prepared it here. It's from the same from Simulink. AEB. Process name is state. We can just leave it as this. Okay, close. And that's it. So it's no, I don't have Simulink anymore. I just start all my modules, including sensors, including my AEB module, which is here, the binary from Simulink. And by simulating, we will get the same result. So I think I have some performance issue on my PC we have seen at the beginning, which may have altered the result. So basically, the simulation stopped with a failure here because we crashed. The AEB doesn't work so well. So we get orange red result for this case. So yeah, that's it for the for how to connect the ADAS. So basically, the simulation runs as normally while the ADAS is doing its thing inside of simulation. To go a bit further, you can use scanner to have your ADAS runs millions of kilometers. On a tabletop computer, it's not very convenient. So instead, you can use take advantage of high performance computing with the massive simulation pack. Basically, you have a Scanner Studio that we have used until now that allows you to create one study case, and with the additional products which are Scanner Explore and Scanner Compute, you will be able to first create hundreds of variations of your scenario, create a test plan, and afterwards send it to a cloud infrastructure, for instance, and have the hundreds of variations to simulate and get the results at the end, and you can analyze them. So everything that I've done today was using the trial version of Scanner. It's easy for you to get on the website. We have a download section. You can just request for a trial version. If you are interested, actually, just leave a message in the chat, for instance, and we can come back to you with the trial version. And what we give also for free is a sample pack. So either for the trial users or the customers. And the sample pack includes a set of configuration for Scanner and data files. You have some samples ready to use to get you started. So we have some for ADAS, for instance, how to connect AEB, ACC, LKA. We have very basic samples which are documented to explain you how they were made, how they were connected into Scanner. You have the sources also, like in Simulink, you have some in Python, in C++, so you can just start from them and modify them to connect your own ADAS if you want. And also to help you, we have every week a workshop like today. So today is a how-to, but we have some other formats, like for instance, more basic workshop about getting started with Scanner. So that's is interesting for new users, like if you are starting with a trial or if you have a newcomer in your team that is new to Scanner and wants to get started, can come, feel free to come. And we also have meetings with workshop that we could meet with the experts that are a bit more interactive. And in the end of all of this, you can ask your questions. It's a good occasion. And you can get the list of all of this on the events page of our website. Don't hesitate to check and to register. One last thing is that at every step of your journey to simulation, AVSimulation is here to help you. So from the beginning, where you have an idea of a study case and you want to know you don't know yet what you need, you don't know how simulation can help you. If you need a simulator or something like that, AVSimulation can help you understand your need and design the relevant solution. Okay, design the architecture, the needs, how much it will cost, etc. When you are making your simulation study, we can help you also to build it. So we provide trainings. We can make, for instance, the connection of the ADAS, what we have introduced today. We can do it, like AVSimulation can do it for you, no problem. We can integrate if you have hardware system that you want to connect in a HIL fashion, etc. We can make text plan for you. We can also help you to operate your simulation system. So we have support. We can also do on-demand studies if you want, etc. So basically, yeah, you have everything that you need to do the study with Scanner, but you know your research. You want to focus on your research, on the results, and we know Scanner. So if you want to focus on your own range of expertise, AVSimulation can take care of the simulation part, and we can give you the optimal result for cost and time, based on the experience that we have had with our customers over time. Okay, so that's the end of the presentation. I think we have 10 minutes left for questions. Yeah, I don't know if they are already in the chat. Otherwise, feel free to add in the chat. Sylvain, is there?
Yes, thank you, Guillaume. Yeah. Thank you very much for the presentation. So yes, we do have some questions that I haven't been able to answer, and I think it's quite interesting to share this. So, for example, people working in ADAS systems are interested in can they use their own vehicle dynamics? Okay, because the vehicle dynamics have a lot of importance in terms of test and validation of ADAS systems, because of course there are the sensors positions are relative to these and is relative to the dynamic model. So one major question is, can we use our own vehicle dynamics model external of Scanner?
Yes, yeah, no problem. So Scanner has its own model, which is Calas, but you can also use what we call external models, where you connect to your model. It can be a car sim, a car maker. So it will be the same for connecting an ADAS, because Scanner is in between, and the interfaces will be the same. So we can interchange a model with the other, no problem.
Thank you, Guillaume. We have another interesting question, is that, and I will maybe also help you on that question, Guillaume, is can you create an ADAS system? So can AVSimulation create an ADAS system for me? So that's very interesting. So we are not at AVSimulation ADAS makers. We provide you, as Guillaume shown, we provide you the tools to interface your ADAS systems to test, and we provide the simulation platform to test and validate these. But the ADAS systems are not part of our jobs. Nevertheless, as Guillaume said, we provide services in order to help you to interface your ADAS systems with Scanner. So we have been using, I will say, basic samples to show you how to get simulation outputs, how to feed your ADAS with these, and then how to send back commands to control ego vehicle thanks to the scanner API regarding the green block, the AEB. So if you need assistance to connect your ADAS systems with scanner API, we can definitively then help you on that point. We have another question about camera sensors, Guillaume. Is that can we get from camera sensors raw images and do image processing, such things like this for specific projects around the camera sensor?
Yes. So yes. So there are some camera sensor inside of scanner that produce an image, and so we have it's a bit the same. There is an API to get the image in real time. You can stream it to your external model. We have also cases where we save every frame with annotated annotations for every frame, like the position of detected elements on the picture. So it's definitely possible. Yeah. Same architecture.
Thank you, Guillaume. And maybe if I can add some information about this, we have been using, for example, camera sensors inside Scanner Studio to train AI, for example, so artificial intelligence. So that's the kind of project we made. We have another question interesting, is that about to test our product or software products. So specifically around ADAS pack, physics-based sensors pack, and NCAP and regulation pack. So are these available for testing, okay, for as a trial? So the answer is yes. All our software packs are available for trial. So if you are interested in test and evaluate our product, yeah, that's perfect, Guillaume. Thank you. We do have on our website here a page where you can ask over a formula to evaluate our software product. Okay, so scanner, also UTAC and NCAP regulations, physics-based sensors, included also Unreal rendering engine with the scanner. So all of these are available for test and validate to test our product. Even if you are already an AVSimulation customer, we can of course share this with you because it's a full everything, all the features are included. So feel free to ask these over the formula or send us an email. We will be pleased to share these with you. We have another question, Guillaume, about our services. So some people are interested in getting more information about our ADAS in scanner in details. And the question would be, do we provide training related to ADAS? Do we have such a training?
Yeah. So yeah, we provide some trainings. So AVSimulation is a certified trainer, and we have a set of we have a catalog of trainings on the website. If you go to services training, we have for the trainings for the basics of scanner and also focused on subjects like ADAS. Yeah, so we have here more advanced training about ADAS and other topics. So these ones are delivered on a regular basis to each of our customers. So yeah, problem.
Okay, we have another, thank you very much, Guillaume. We have another question about how to connect ADAS hardware, etc. And so it's more relative to, for example, if you have an ECU connected on a hardware in the loop bench and has a camera sensor, let's say, imagine, and you would like to test it with scanner. Can we do that? Can you provide us more information about what we will need inside of scanner? What would be the pack that we will need?
you'll need the RT target spec. Very often there is a RT platform between scanner and ECU or whatever hardware there is. And we have the RT gateway that is included in the RT pack. Okay, so that's the real-time target spec here. That gives you access to the feature, and the architecture will be the same. It basically gives access to API over on the real-time targets. AVSimulation also provides the service of designing the whole architecture. So we can provide a service with a turnkey system if needed.
Thank you, Guillaume. Okay, the time's going fast, so maybe a last question. I think that maybe two last questions, so that I think it would be very interesting for a lot of participants. The first one is, do we support different operating systems? Because what we have shown here was on Windows, obviously. So could it be possible to do it with some other operating systems or specific interfaces?
Yeah, so Scanner runs on Windows and Linux. We have interfaces to ROS. We have interfaces with RT maps. We have interfaces virtually to anything based on the architecture of Scanner. So yeah.
Good. Thank you. Yeah, I think that's perfect. And maybe one last question, Guillaume, and I think that would be interesting. Just we have a question about which kind of NCAP and regulations on the shelf product are we able to offer today? Yeah. So what kind of products do we have?
Yeah. Okay. So today we have Euro NCAP and US NCAP. And also AD NCAP, AD scenarios for NCAP, and more are coming. Like we are working with Utac, which is a laboratory that runs NCAP tests, and they are working with us to create the newer scenario for other regions in the world and other cases of the NCAP.
Thank you, Guillaume. Thank you very much. Just so has a conclusion on that point. So do not hesitate. All of these NCAP and regulations are available for test on your side. We have a trial version for free that you can ask. So do not hesitate to ask us for that. We can provide it to you to test it on your side. And yeah, and just keep in mind that of course the goal of simulation is also to accelerate your test, warranty the security of your collaborators, and make sure that you have a very complex situation to test and validate your ADAS systems in the various situations. So of course we offer different way to execute the simulation. The one we shown was on a workstation, but of course to test and validate ADAS we also offer the massive simulations pack that allows our customers to run to benefit of Scanner features to run simulation on HPC cloud architecture, including Docker, etc. So if you want to do a massive simulation with NCAP, then you will be able to do it. Okay, I think the time is gone. Thank you very much, Guillaume. Thank you very much to everybody who has been following this webinar session, this workshop session. I do apologize. I have not been able to answer to all of your questions through the chat. So if you put your name, I will be able to get back to you by email following this meeting. If you put it as anonymous, it's still the time to put your name, so I can try to get back to you later on. Otherwise, do not forget that we have every week we offer a webinar session led by one of our engineers. So next week is getting started with Scanner, and we will have also a specific workshop session dedicated to NCAP and regulation at the beginning of May, and we will have one of our experts from UTAC-CERAM also to answer to your questions, so that will be a good opportunity to learn more about this project. Once again, thank you very much, and I think we are good for today. Thank you, Guillaume. Thank you to everybody. Have a good one.
Thank you, everyone. Have a good day.